All right, check number 3. So, again, when you're a brand name, people have unfair expectations. Here's the expectation they had for Apple's iPad. The number 3 started getting too hot, and it became news almost instantly. It even became news in places that shouldn't have news. This is a weather website, and the headline is Apple products overheat in cars. It's completely unfair because the whole point is that, oh, cars can get to 115 degrees. Any product could overheat. It could be candy bars. It could be any electronic product. They put Apple on there because it became a story, because this was a story, and because they wanted people like me to find it if they did Google searches. Right? Again, unfair expectations from irrational consumers, but you still have to live up to them. So what can we do? Oh, here's another cool one. This is what you want to avoid. The products being recalled for overheating. And what I found interesting about this one, the cable would overheat when pressure is applied to one side, something shorting on the inside. So again, 2 simulations in one. Check for max overload condition, step 1 that we talked about, but then also check for heating. So what can we do about this? Well, I could have downloaded a flashlight from GrabCAD, a really cool consumer product design flashlight, and we could have tested that, but I didn't. I downloaded this one instead. Sorry. The reason I downloaded that one instead is that one has guts inside it. That one had a lens, that one had a reflector, a battery, right? This other yellow one, the cool consumer product one, didn't have anything inside it. But again, both of these were available for download on grabcad.com. Again, I'm going to plug that site. Great way to get models to start doing some of these analyses on your own. So what did I do with this flashlight? I wanted to see if I put a heat load on the bulb, would the case get uncomfortably hot? Okay, here's a real quick shot of that. You can see the bulb's getting very, very hot. The case is getting not so hot. I didn't put any vents on it, but eventually you could have. Right? The whole point of simulation is to explore. What if I put vents on it? What if I don't? What if I put a fan inside it? So this one doesn't show the case getting very hot. But what if you leave it on for a long time? This is what's happening with the Apple iPad. Here's 0 minutes, case all nice and 70 degrees. Here's 10 minutes. The front end is getting a little hotter. Okay, that's where the bulb is. And honestly, I made this switch out of copper. I wanted to see the switch get too hot for a person's finger, but that's not what happened. What happened is the heat's coming from the front back. And about 30 minutes, if you leave this flashlight on for 30 minutes, sorry, if you leave this flashlight on for 30 minutes, then the case starts getting up to 115, 120 degrees. Now, I always like to put things in a sense of scale. Is that too hot? Is that not hot enough? A good shower temperature is 104 degrees. But if you start looking in the codes, a dangerous shower temperature gets up to 115, right? And that's exactly where this top line, this top handle, is getting to after about 30 minutes. This is what's happening with the Apple iPad. If you use it for 10 minutes, maybe you're okay. If you use it for a long time, maybe that's what's going on. And then you get Apple reviews like this. The iPhone burned my leg, right? This is the iPhone, not the iPad, but same idea. You also get stuff like this, where Consumer Reports starts putting infrared cameras on your products and says the iPad hits 160 degrees, which again is too hot for a shower, right? That's in the danger zone for showers. All right, so I think heat check, especially for electronic products, very important to do. How do you do it? There's 2 ways. We went over this in the last webinar. Real quick, if you're dealing with conduction, use a thermal study in Professional. Good for iPhones, iPads, things that are densely packed, not a lot of airflow. Very good thermal study. If you've got all 3 modes, use the flow simulation. How do you know when you need flow simulation? If your machine has a fan, a vent, reflectors, coils, those all imply convection, radiation. If your machine has any of those things, your product has any of those, go with flow simulation. Make sense? We get this question a lot on our hotline, so that's why I keep putting this up in both presentations. let me break real quick in case anyone has to go. Al, any questions from the crowd so far?
No. You've been explaining things fairly well and thoroughly, so apparently they don't have any questions.
All right, awesome. We got 2 more to go. I'll try and get you guys out of here in 10 minutes.